Today's lesson is 7.4 and we're talking all about tree diagrams. Our goal is to use tree diagrams to find expected outcomes for chance events. Below you see two examples of tree diagrams, just to show you that they can be tilted to the side or they can be up and down. They can look different ways and still be a tree diagram. Looking at Math Journal page 257, we're going to look at this whole page together. Let's start with the math message at the top. The diagram at the right shows a maze. A person walking through the maze does not know in advance how many paths there are or how they divide. Pretend that you are walking through the maze. Each time the path divides, you select your next path at random. Each path at an intersection has the same chance of being selected. You may not retrace your steps. Depending on which paths you follow, you will end up in room A or room B. So number one, in which room are you more likely to end up, room A or room B? So what we're going to look at the entryways here. So to get into room B, we have 1, 2, 3 possible entrances. Room A, we have 1, 2, 3, 4. So we're definitely more likely to end up in room A. We have more entrances, which means if we were going at random, we would be a little more likely to go in there. Number two, suppose 80 people took turns walking through the maze. About how many people would you expect to end up in room A? So what we're going to do is we're going to take our marker here, and let's say we start with 80 at the top. Now we have an equally likely split here, so let's erase these old paths so we don't have to look at those. But we have an equally likely split, so here, if we split 1, 2, 3, 4 ways, it means that each way 20 people would go there in each of those first 4 paths. Then, if we continue, those split off into 2 each. So each doorway would be 10 people that would go through each doorway. And remember, we said we had 1, 2, 3, 4, 5 entrances for room A, so that means that we would expect 50 people to go on room A, which means then we started with 80. So if we were doing our math correctly, 80 minus 50 would mean that we would expect 30 people to go in room B, and we can check our work here by going and looking back. If we look at room B, we have 1, 2, 3 entrances with about 10 people per entrance. That does give us 30 people, so we did that correctly. Looking below now, we are going to be filling in this tree diagram. So this is exactly what we started doing up at the top, and luckily you have your math journal page so you can see, and zoom in as much as we can. But what we're going to do here is start at the top, and this is what I started doing on the tree diagram previous, and we just want to be able to write the numbers here. So we started with 80 people, and then we said that 80, that branches off 4 different times, and we are assuming that it's equally likely that they will choose one or the other. So 80 divided by 4 equals 20. So each branch will branch off to 20 people. And then from there, if I'm looking at each box of 20, each of them splits off equally into 2 groups, which means 20 divided by 2, we get 10, 10, all the way across. All of these are equally likely. Now some tree diagrams will throw something else at you and throw in a 3rd branch. If we did that, like for this room, then we would not have 10 here. We would have to divide 20 by 3 or 4 and find our new number. Your assignment today is in your math journal. You have pages 257, which we just did together, so you're done with that. 258 and page 259. For IXL today, you're going to be reviewing some other concepts with II1, II2, or II3.